Hello and welcome. This is Jim Coffin with Rankin Technical College. This video is about handling user input and data conversion for TypeScript. So we will cover 4 different phases of handling user input and data conversion. The first phase is the capture phase. That's where actually we capture the raw user input. Then we have the execute the convert phase. And this is where we transform unpredictable string data into usable numeric values using like parse float to prevent concatenation errors. The third phase is the validate phase, and this is where we build kind of guardrails using it is not a number to detect invalid data and prevent script failures before calculations occur. And then the final phase will be the format phase, is that's where we kind of utilize the like toFixed, or others as well, but toFixed to polish raw calculations into user-friendly strings specifically for currency or precise measurements. So first I've got a presentation we're going to go through, but I also want to just kind of get our Visual Studio Code set up again and kind of run through that process that we did in the previous video. Basically initializing our Node project and our TypeScript project and kind of just running through that again. Repetition is good. And also I'm going to point out a couple things. We're going to make a couple little other changes as well. Well, let's first open up a terminal, new terminal. And in here we want to go ahead and do an npm init. And I'm going to bypass the questions again. I just want to mention, we don't really always want to do this, but just for now, we're going to go ahead and do this for simplicity reasons. Okay, so that went ahead and created our file. So one thing we're going to do a little bit different here is we want to tell Node, right? This is our Node. This is the package.json file from Node that Node creates. So what we really want to do here on this is we want to make a little change here. So CommonJS is the older way to do module for Node itself. We want to actually do what's called ESM modules. And to do that, we just go ahead and change this to module, just like this, okay? And it'll give you a suggestion. Save that. And obviously I just gotta want to mention, I probably haven't mentioned this already. If you want to autosave, it's an option. Like I just clicked it again, so it will be turned off. But if you just want to go ahead and enable autosave in Visual Studio Code, I don't know what you currently have set up, but if you want, you can do that. So if you make a change, it's automatic. I always have a habit of always doing Control S all the time. It's such a habit that I still do it all the time anyhow, but every once in a while I kind of forget, and at least that autosave will catch it right away and automatically save it. Okay, so we went ahead and initialized our Node project and changed this to module. And then next we want to go ahead and we're going to install TypeScript again. Okay, so we're going to kind of do this all the time this way. Just you can install it at the root globally TypeScript. Sometimes that's not best. For like best practices, usually you always want to do it within the project itself. And the reason for that is, you could be working at a company and there could be multiple different projects. Well, they may have created a project, an application based on an earlier version of TypeScript. You don't necessarily, obviously it's always good to upgrade for the right reasons, but sometimes you got to be careful about that. And it's sometimes best just to make sure the way you can set up your projects to use certain versions of TypeScript, right? Because it'll put it in the package.json file as well, right? What version of TypeScript you're using. So you kind of really want to, if you install TypeScript in the global at globally at the root, then it will, everything will always use that, and in practice it's probably not the best thing. So what we're going to do is for every like project, we go ahead and install that, as far as from a at the development level, right? Local development. So here we just do the install, npm install save dev TypeScript. Instead of dash dash save dev, you can do dash uppercase D if you'd like. I like to do that just so it kind of reminds you what you're actually doing there. Okay, so that we've done that. Now we've got, when we do that, it's gonna create a node modules directory. It has our TypeScript in here, right? And inside that, it also creates its own package.lock.json file, right? You don't need to worry about anything really in there 99.9% of the time. So here, it did also create this one, right? So here's basically it's using our default thing. These are all things that you could have changed when we created it. We did the yes to avoid it. But okay, it has that, and then here's your JSON file. And you never want to do anything with this lock file. Don't touch this, just leave it alone, okay? This JSON file here, obviously, remember we changed this from common.js to module. And look what happened also is once we did this install of TypeScript, it added this as a dev dependency, okay? A dev dependency. Because what we're really doing here with this TypeScript stuff, you got to look at it as, we're writing things in TypeScript, but our final product is really a JavaScript file, right? It gets transpiled into JavaScript. Our TypeScript gets compiled into JavaScript. So this is just a tool that we're kind of using locally, right? This is a tool we're using in development. So it's kind of best just to go ahead and use this as a dev dependency, right? So there's that, and this would be the latest version. Whenever you do this, it's going to just go grab the latest version of this module, right? So we're always using the latest version, okay? Now that can be controlled by having it in there, and then you can recreate the project from a package like a older package.json file, and I'll show you that later. I don't want to get too far off track. So, okay, now we've installed our TypeScript project, right? And then we want to go ahead and do initialize our TypeScript project. We installed our TypeScript module, but now we want to initialize our TypeScript project. So we do npx tsc --init, and this is going to create that tsconfig file, right? Right here. And then obviously we go in here and we're going to, once again, change our compiler options, okay? And in here, so I just click that link. And so we're going to come in here and we're going to do compiling and running the outputs in node.js for now, all right? So let's just go ahead and take that and copy that. And we're just going to basically replace this whole thing with that. And we're going to save that. And so we're good to go. And so then we're going to go ahead and start going through the presentation. We're going to come back here in Visual Studio Code and look at a little bit of code as well, okay, when we get there. So in the presentation here, this title is very fitting, from chaos to control. And the reason you want to know, what does it mean by chaos? What do you mean by chaos here? With user input, users will put any kind of thing in there. You never know what a user will drop in there. And when you're dealing with an application and you got a lot of people using it, you'd be amazed at what people do. They accidentally input images and upload files and do all kinds of different things that they didn't mean to do, right? They'll put in special characters. They cut and paste from a Word document in there, or any other kind of document has special characters, different things. So you never can trust user input. It's very chaotic, right? Users will do all kinds of crazy things. All right. So user input is the Wild West, right? Raw input from a console is just a string of characters. It has no meaning, no type, no rules, right? To your program, 5 equals 5 are the same kind of chaos, right? This is a primary source of bugs. So the chaos I was talking about is actually a little more chaotic as far as user input, but it's kind of referring to just that, sometimes people will put in strings instead of numbers and everything else, right? So here, 5 string plus 5 string equals 55, right? Not 10, right? It's just doing concatenation in this case. So your toolkit for taming data. To transform unpredictable strings of reliable data, you need to process, and you need a process and the right tools. So we'll master the 4-step workflow to impose order on user input. And that's what I kind of already just mentioned earlier. We're going to do the capture. We're capturing the input from the command line, and that's going to be basically what the user is inputting somewhere. Convert, we turn text into the usable number. Validate, we reject bad data gracefully. And then we format, we present the final result cleanly. So step 1 is opening the channel. And so what we use is called readline. Okay. The built-in Node.js readline module creates an interface to read data from a stream, like a terminal console. Okay. This is the fundamental first step to building any interactive command line application. Okay. So in this case, we're just doing command line. We're looking at it from a perspective of building a interactive command line application. Okay. So let's go ahead and take a look at some of the code. Okay. Let's bring up Visual Studio Code here again. Okay, I'm going to create a new file in here, and I'm going to call it, it doesn't matter, for demonstration purposes. But remember, we're using TypeScript files, right? I put in TS for TypeScript, right? Okay, so let's go see what Node has regarding Node readline. So go down here to Node's documentation. Oh, what happened there? Okay, so here is the Node.js API for readline. And these are your different options. Okay. And obviously I know some of this is kind of hard to understand to a certain extent, but we're going to be using readline promises. Let's see what this shows us. Okay. Now we're going to do something probably a little more basic than that. All right. Well, first here, what we want to go ahead and do is we're going to use the readline module that's built into Node, okay? So we don't need to do like an install on this like we do other things, right? This is a built-in Node module that's available, okay? Okay. And a lot of times in Visual Studio Code, it's going to tell you something's declared, but its value is never read. That's not necessarily an error, more of a warning. Obviously you want to remove them if you don't use them, but we haven't used it yet. So that's why it's underlying as red, right? And then within the readline, it has some different functions that are available, right? You can You do like what's called standard in and standard out, input and output. Okay, and there's and that comes from what's called the node process. All right. All right. So we got our input and our output. And then we want to go ahead and what's called create an interface. Okay. So we're going to create an interface now with our input and our output. So we use readline.create interface, and we pass in both the input and the output, right? We have two variables, input and output. Now we want to capture data from the terminal. So we can do it like this, and await. What await's going to do is going to await. So when it starts executing, when you have this await here, it's going to post this question to the terminal, and once it has been entered, okay. Once it has been entered, then it will continue on. It will populate this, okay. And so then we also kind of want to go ahead and log it out. Let's do a quick example here. All right. So we imported readline, which is a node module, right? No, I should say what's it called, a native node module, not to confuse it with other modules. Like TypeScript is more of like a third-party module, right? Not a specific native node module. This is what's called a native node module. It's all part of the Node framework, right? Or part of Node.js, right? It's part of Node.js. And same with this here, okay? This is all part of Node.js. All right. So let's take a look at this now. So what do we do here? We should be able to, let's see if everything's right here. If we set everything up with all of our files, should just be able to run npx tsc, right? Let's see here. Okay. It created our user input.js file right there. Okay. I do want to point out, since we're here, so, you know, and we did this in the TypeScript file, but whenever you use the, for this course, we really want to use the more modern one, which I was talking about, the modules, the ES modules. And the way to tell, even by looking, let's say you looked at a file, a coding file that's a node file, right? And if you look at it, you can tell by looking at it if you're doing any, you know, any imports and stuff like that. If it has import, you're using ESM modules. If it says require, then that's actually using the common JS. We always want to do imports, which is the ESM module, okay? So we have that. So now we can go ahead and execute this, right? So to execute this, we just do node. And then what we call it, user. Just hit the tab there, hit enter. Enter a price. Okay. And like I said, when it's executing this, the read line, it's waiting, right? It's sitting here with this await. It's just waiting for me to enter something, hit enter, right? And once it do, it's going to populate this answer, right? And then it's going to continue on and finish the rest of this file. There you go. Now, we didn't really do this in a way that exits this cleanly. Okay, no big deal though. We'll just do a Control-C just to get out of there. Okay, still, it hangs there unless you do it a certain way. But for this purposes, it's not a big deal. So there you go. Okay. So this one was a little bit different. The example I had in this one, basically same thing though, right? You're importing your native node modules, right? You're doing a read line. You create an interface and you pass in an input and output. Okay. Here you're asking a question and waiting for a response. And here, what is your favorite number? Mine was somewhat similar. Mine was just enter the item price, whatever. And so then same thing here, and then you're going ahead and logging out. And here, this is what you do to close your interface when you're done. So yeah, let's just go ahead and for the heck of it here, we'll enter that to make sure that works correctly here. Let's just do that real quick. Oh, wrong thing. Okay. And always remember you're updating the TS file, not the JavaScript file. Okay. So here we're doing what? LRL, right? Dot. And it's very good with I was kind of saying it's going to give us the completion here, but it really didn't, did it? So let's just run this one more time here and do that. Enter the price, hit enter, print it out. Actually, it didn't even work anyhow. I wonder why. Okay. Well, I'll look into that and let you know why that didn't. Oh, I have to compile it, right? And I'll tell you what, I'm going to show you. I'm going to show you another way to handle this so you don't forget to do that here in a second. So I'm going to do that, compile it. What did I do? I accidentally. Can I find node process? So when you're using TypeScript, you may need to update your Node.js type definitions to include this promises API. I don't know. Sometimes like it'll work one time and another time it won't. So to do that, you can do this. Okay, and I'll include these packages, types packages. Okay. Sometimes it was strange because sometimes it'll kind of work and other times it won't. Readline dot close, and actually, so now the editor's actually picking that up. Oh, that's kind of interesting. Yes. I'll make some notes on all this so you have this as well. So now that we got that, okay, now let's run our npx TypeScript to compile it. Now that's good. And then if we go ahead and run our node on our JS file that was created, we enter our price, hit enter. You entered a 100 and went back to the thing, so it went ahead and closed it correctly this time. So, okay, yep. Sorry about that. Yep, you also need to do this for TypeScript projects. Okay. Okay. So next, let's look at step 2, forging a number from text. So the challenge input answer is still just a string. You can't perform math on it. So the tool is to use to parse float, to parse a string argument and return a floating point number. So let's go ahead and do that. So here, we're going to do our convert here, right? So we're going to take our answer, we're going to parse it to a float. Now we have this price. We'll just do this. Why not? We're going to run this. Just to make sure everything works, everything looks good. Okay. Really didn't change anything. We would have just left it a string. Still would have gotten the same thing, just to return the string, right? But now it's actually a, now it's a number, right? It's a float, floating point number. So just to make sure that we can perform some mathematic function on it, let's just multiply this by 2. It's not really relevant for the price here, but let's just make sure that that works. And we'll go ahead and compile it. And let's run it. I'm going to put in 100.22. So it should come back 244, right? There you go. Okay. So that was our conversion. Now we want to build some guardrails around that. Okay. So what if the user enters hello instead of a number? When you do a parse float on a hello, it's going to result in not a number, right? So which will corrupt all future calculations. So the tool is the global is not a number. Function checks if the value is not a number. Use it to validate input before you use it. Okay, so let's go look at an example. Add that to our code here. So let me get rid of the price multiplying this. And so now we want to go ahead. We already did our convert. Now we want to do a validate, right? And so we want to check to see if price is not a number. If it is not a number, we want to log a message so we can send that back to the user, right? And then we need to close our read line and return it, right? Before we had it, because our read line's open, right? Until you close it, our read line's open, right? Even though we moved, you put the values in there, but the read line itself is still open all the way until you close it, right? So if you do have an error, you kind of want to make sure you close it first, all right? So we can do it like this. So let's see here. I think I'm missing a couple things. No, I think we were looking good, okay. So yeah, we can't have this return here. Let's get rid of that, save that. So if it's not a number, do a console log and then close our read line. Which in essence would close right here as well. So, but all right, no big deal. So here, let's go ahead and compile this again. And run it. And now if I just put in some string, hit enter, invalid input, please enter a valid number. Okay. So first you kind of want to check, right, before you do any kind of computation or anything. So for our price here, let's do some kind of a tax. So let's check that. So let's come up with a tax here on our price. There we go. And We need to add our tax to our price. Let's do that. And then okay, so that should work fine. Yeah, well, let's do a console here. Why not? And we're gonna put total here just to see that work. Compile this thing again. Okay, looks good. So we got our is not a number now to protect ourselves there. So now we want our step 4, we want to polish the output using the toFixed, right? Which, you know, you've all done things like this before, I know. So basically, we're going to do our total.toFixed, and that's for a display, right? And actually, we're creating a display total being a string here, right? We do want to do that as well, right? Okay. So let's do a toFixed on our display total. And you could, you know, do this as a string here, right? Because basically, what you're displaying is always going to be a string. Once you're finished this, we should have done numbers, you know, we should have done this a little different. A couple things here. That's all right. So, but here we got a display total. We're defining this as a string because the only purpose of the display total is just to display it, right? It's not to do mathematical functions on a display. So here we're doing this, and you know, you need to make sure you got another extra dollar sign, $1 for the variable itself, right? And the other dollar sign is to display that as a dollar sign. See, let's clear our screen here. Let's compile this. And let's run this. 200 times 25. And so you enter that. Your total is $214.27. So, okay. So basically, here's a complete workflow in action. You know, here's the 4 tools work together to create a robust and user-friendly input processing script. So a couple things we learned in the process here. We need to go ahead and make sure that we import the node types, right, for TypeScript. And I'll create a document that has those kind of notes in it for you. And then the first thing, so we want to capture our input from the read line. And we know that we use the await because it'll await until a response is entered before it's going to do anything. It's going to just, you know, the script will just pause until the question's been answered, right? Here we're doing a convert, which we're converting the raw input from a string to a float. Then we're doing a validation. We're checking to see if it is not a number. If it is a number, if it's not a number, we're going to return an error message. Else, we're going to go ahead and format it and print the result. Okay. So making it work is the first step. Making it clean, readable, scalable, and robust is the mark of a professional developer. The tools are essential, but the discipline you apply is what defines your craft. The foundation of type safety: use explicit typing. Always declare your intended type. Let count equals number. This is the primary benefit of TypeScript and prevents entire classes of bugs. Avoid any. Defeats the purpose of TypeScript. Use the specific interface or unknown. We didn't really do that in this example, but we've talked about this before. Define the data shapes with the interface. Use the interface to define the expected shape of an object. This is a critical skill for the burn stack. Okay, these are just our basic stuff that we've all discussed already. The rule always check for null. So the rule always check for null or undefined before trying to use a variable, especially one from an external source like a database or from a user's input, right? Like you just hit the enter key again and it would be null, right? In TypeScript, strict null checks are a powerful feature. Using them proactively prevents runtime errors, like cannot read properties of undefined, one of the most common bugs in JavaScript. So from raw string to intentional structure, handling user input is more than a single task. It's a core discipline of software engineering. You are taking the most unpredictable part of the application and using your tools and craft to shape it into something reliable, predictable, and safe. This is a foundation of building professional grade software. Okay, so that's all I have for this video. Please let me know if you have any questions and have a great day. Thank you.